I'm Stuart Thompson, editor of Digital TV Europe. I'm here with Stefan Beule, who is VP Solutions Architecture at ARRIS. Stefan, we're hearing a lot about IP migration. Why does it make sense for cable operators to migrate their video platforms to IP?
Very good question, Stuart. So in fact, Dvb-C has been delivering and still is delivering good quality TV services to millions of subscribers in a very economical way. Yeah? And also IP video is not new. IPTV operators have since many years now delivered TV services over IP. So why would a cable operator move from Dvb-C to IP now? Well, in fact I see three main drivers. Yeah? So a first driver that I see is the multi-screen evolution. So over the last years, operators have been investing in an overlay network to deliver their TV services to multi-screen devices. Yeah? And what we see now is that this technology and these deployments are getting such a scale and maturity that our operators start to say, okay, why do I have these two networks in parallel? Isn't there a way to converge them, to have just one network instead of having to operate these two systems in parallel? So that's one big driver. The second big driver is the change of the consumer behavior. So consumers are watching much more on-demand content. Yeah? So it's not only SVOD services from Netflix and the likes, but also the operator's own services are watched much more in a time-shifted way. Yeah? So you have network DVR services, catch-up TV and so on. And operators then have the choice to expand the spectrum that they assign to their TV services to cope with that growth. Yeah? Or try to do that in a much more economical way on IP. And you see that operators are looking to get that growth to on-demand services on IP. So there's a natural flow from the end-user behavior to invest more on the IP side. And then the third big reason is that the spectrum on a DOCSIS network is a scarce resource. And it's shared with the broadband services. Yeah? And there is an ever-increasing demand for more broadband capacity. The billboard speeds are getting higher and higher, right? So there is a good economical case to make to see, okay, can't we converge the video spectrum with the broadband spectrum? Yeah? Also from a usage perspective, what we see is that the internet busy hour, the peak in internet usage is slightly before the TV busy hour. And so it makes a lot of sense to also look for convergence on that sense. So these three factors make that operators are really looking at this convergence at the moment.
What are the challenges that operators face in making this migration?
Yeah, so the first challenge is not so much a technical challenge, it's more a planning challenge. So what you really need to do is before you start rolling out this migration, is to look at the capacity modeling. Right? And there are a lot of unknown factors in there and multiple things moving at the same time, which makes it challenging. So first you have the fact that you're moving from what is typically a multicast environment to a unicast environment. So adaptive bitrate delivery on this multi-screen networks is unicast in nature. Right? So that increases the amount of traffic that you have. On top of that, you have more bandwidth per channel or per video with 4K coming, Ultra HD. So you see a potential huge increase in bandwidth needs from that side, right? So and then at the same time, you're remodeling your cable access network. You're going to distributed access architectures, less subscribers per service group. It changes the whole statistics of how much common viewing there is within a service group. So modeling this all out is a challenge, right? So that's a first big challenge. The second challenge is to be able to still keep the same quality that you had before, right? So Dvb-C has been delivering video in a very good quality over the last years, and there are things that might sound small in their own, but really deliver a lot to the user experience. For example, when you switch on your cable box, a few seconds later you get a channel on your TV. If you switch on your game console and you want to get video, it can take up to a few minutes. Right? And this has been, over the last years, already a differentiator for cable operators, where it takes the time to video on a cable network is typically much shorter than, for example, on an IPTV network. So you want to be sure that you don't get rid of the goodies of what you have now when you make that migration. And then finally, probably one of the biggest challenges is to deal with the legacy in the home. So operators have deployed a lot of legacy set-top boxes. Some of them are hybrid, so capable of doing as well IP video delivery as traditional. Some might still be just QAM boxes. So to manage that whole migration is also a big challenge.
Now, are there any specific innovations in technology that can help them make the transition?
Yes, absolutely. So on the one hand, there is, in terms of modeling, I mentioned modeling as one of the key challenges. There are very good tools from that ARRIS has, for example, from the switched digital video domain, where the same statistics apply. So you can use those same modeling tools to help you to do the planning of your broadband infrastructure. Yeah? There are also new technology evolutions. Like, for example, we work together with Cable Labs over the last years to develop a technology called multicast ABR. Yeah? So basically what you do is you're going to take a unicast stream from your CDN, transform it in a multicast stream on your shared cable access infrastructure, and in the home you transfer it back to a unicast stream. So that gives you optimization of the access network, which makes it more affordable to do that transition. Yeah? And then also in the standards, you see a lot of activity to define what is then called broadcast TV quality adaptive bitrate streaming, where you try to lower the latency. Right now, latency on multi-screen is sometimes 30 seconds to 1 minute behind what you get on your main TV. So the standards are now being optimized to get that down to below 10 seconds.
What do you think the roadmap to this all-IP future will involve?
Yeah, so what we see there is first, we think that it will take many years. Like it took a lot of years to go from MPEG-2 to MPEG-4. So now we think again it will be a very long transition, right? So, and we see the transition happening in two parallel paths. So on the one hand, there is this multi-screen path, yeah, where operators are deploying their TV services more and more to multi-screen devices. And what we see now is that they are starting to add what is then called OTT set-top boxes. So set-top boxes that are pure IP, leveraging the same adaptive bitrate streaming. And in the first instance, it will probably be used for the second TVs in the home. Yeah? And then in some regions, you might see a deployment for the first screen. Yeah? And it might even be used for over the top, so to deliver TV services outside of your own footprint. So that's one evolution, more in the multi-screen trend. The other evolution is within the main screen itself, so within the set-top box environment itself, where you see that services are being migrated step by step from traditional Dvb-C to IP delivery. So first it starts with VOD. You move your VOD from traditional VOD pumps to IP. Then you see network DVR moving over. Then you see the long tail channels moving over until finally, and that can take still many years, the short tail channels, the most popular channels, are moved over also from Dvb-C to IP. So it will be really a multi-year transition period that we are starting right now, or that is already happening, I would say.
Finally, Stefan, what will the migration to IP achieve for cable operators in their competitive battle with other service providers such as fiber and telecom operators?
Yeah, so that's a very interesting aspect. So why do all this? So the first thing is that this new IP video solutions are using the latest software tools and methodologies. So it's all about microservices, agile development, DevOps model, using open source component and so on, where traditional Dvb-C networks are more hardware bound and more rigid in structure, right? So this whole new IP video solution, you could call it software-defined video networks, right? Are going to offer much more flexibility to introduce new services, to get new features into the market quickly. Yeah? And then also a very interesting aspect, I think, is that the fact that the IP set-top box is going to become much smaller, yeah? And that could much more cost-effective, and that could change the whole customer acquisition dynamics. Yeah? Like, for example, it's a set-top box that you can fit in an envelope. You can put it on the post. It fits in a letterbox. The subscriber gets it at home. It's very easy to install. You don't have a coax cable to connect. You just plug it in the HDMI port of your TV. You use USB on the TV to power it, and the video is delivered over Wi-Fi, and off you go. Right? It's becoming much more easy to acquire new customers and test out new business models. Yeah? So and at the same time, so we see that evolution, but at the same time, by moving to an IP environment, there is also an opportunity to innovate on the set-top box itself. So you can start to use the set-top box also for other services. For example, we are discussing with operators to integrate microphones in the set-top box and then use it as a voice assistant, where you can use the TV not just for the speakers, but also as a feedback, as a nice screen to have feedback on what's going on. And that opens then again a whole new set of services in the IoT space, e-health, elderly care and so on. So it really opens a lot of new opportunities for new services around this IP video infrastructure.
Stefan, thanks very much.
Thank you, Stuart.